Right, hello. This is a little extra one on probability for the functional skills because I've just seen this has crept into the curriculum. So we'll have a look at this. So it's going to be probability, but we're going to use trees. Yeah, and we use this when we have multiple events that happen. So we can calculate different probabilities when there are multiple events, such as something like this. We're going to have two dice. There's one, there's two, and we're going to throw them one at a time, or both together. It doesn't matter. 1, 3, 5. I don't know what numbers appear where, but anyway, the chances of getting any single number when you throw a dice once is 1 out of 6 because there are 6 sides and we're only looking for one. It doesn't matter which number we're after. And so again, if you throw the second dice, you're going to have the same probability. And it doesn't matter whether you throw them at the same time or one after the other. If you're looking for a particular number, any number, this is the chance of getting that number. And right, so if we want the probability of getting say two consecutive numbers, say we're after a 3, we've got a 1 in 6 chance of finding a 3, and then we got a 1 in 6 chance of finding a 3 the second time, and so we multiply the two probabilities together, so we get 1 in 36. So obviously we've got a less chance of finding a particular number followed by a particular number two times than we have just once. So this is where we have a probability tree, which is a pictorial representation of what we're after. And it's much easier to see when you do it this way. So say we have a bag, and in the bag there are some coloured counters. Yeah, just small discs. Yeah, like this. So we can have a fill it in. Yeah. So we can have a red one, and we can have a blue one, and we're going to pick these counters out of the bag, blindfold as it were. We don't know what there is. We can't see. So when we pick a coloured counter out of the bag, we're going to keep it. And when we keep it, there will be fewer counters in the bag, so the probability of picking a counter for the second time will change. So say we've got 10 red and 5 blue. Right. So this is red, and this is red, and this is blue, and we do the same. Red, blue, and red. Okay, so the chances of picking a red one out first time are there are 10 red and there are 15 altogether. So this will be 10 over 15. And the chances of picking a... Oh, that should have been blue. Why did I write... Why did I write red? Too many red counters, that. So it's going to be blue, isn't it? So the chances of picking a blue out first time is going to be 5 out of 15. Now imagine we have already picked that red one. Oh, hang on. Pick the red one out. So now there are only 9 red and only 14 in total. So to pick another red, it will be 9 out of 14. Now to pick the blue, there are still after a red, that is, there are still 5 blue in the bag, but there are only 14 in total. So now we've picked a blue, we come down this way. To pick another blue, there will only be 4 blues left, but there are now 14 in the bag. And to pick a red one after we've picked a blue one, there are still 10 in there, but now there are only 14. Now the thing is, we can get a probability of what's the probability of picking 2 red ones in a row. Now remember the dice, we multiply the probabilities to equal the final probability of 2 events. So the first event is 10 out of 15, and the second event is 9 out of 14. So if we multiply those two together, 210, we have a 90 over 210 chance of going red followed by another red, as long as we keep the counter. If we don't keep the counter and put it back in the bag, then the odds remain the same. So it's too easy to work out when it's all the same. It will be 10 out of 15, 10 out of 15, 5 out of 15, 10 out of 15, 5 out of 15, and so on. So this is much more interesting when the odds change. Now, the probability of getting a red followed by a blue will be 10 over 15 times 5 over 14. So that will be 50 out of 210. And a blue followed by a red will be 5 over 15 times 10 over 14, which again is equal to 15 over 210. And these two middle ones, whether it be red blue or blue red, are always the same. Doesn't matter how many we've got. And the blues are 5 out of 15 times 4 out of 14. Again, 5 fours are 20, but it's out of 210. So because there are half as many blues as red, we can see that the odds of getting two blues in a row are much worse than getting two reds in a row. Now if we take these numbers here, 90, 50, 50 and 20, we will see that they all add up. That plus that plus that plus that, they'll all add up to 210. Well, of course they will, because there are only 210 different possibilities. Yeah, so 210, oh, let's write that again. 210. Right, okay. So we've got 210 out of 210. That's all the possibilities there are. Have another go at one of these. So use different numbers, yeah? Right, okay. So now what we're going to have, 12 red and 8 blue. So we've got this is our first pick. This is our second. So we're going to have red, keep reds to the top. Red, red, red. Blue, blue. Oh no, that's red up there. This is blue going down. And this is blue. So we're going to keep them again. So to get a red is 12 out of 20. To get another red, it's 11 out of 19. To get a blue, there are 8 out of only 19 left now. The initial blue is going to be 8 out of 20. And a red is going to be 12, and there are only 19 left in the bag because we've taken the blue out. And now to get a blue, we've taken one out, so it's 7 out of 19. Okay, the odds of getting red, red are 12 out of 20 times 11 out of 19. And that is 132 over 19 times 20. 2 19s are 38, so it must be 380. So red followed by blue is 12 over 20 times 8 over 19, which equals 12 8s are 96 over the 380. We know this is going to be the same, but we'll do it anyway. 8 over 20 times 12 over 19. That's 96 over 380. And this one is 8 over 20 times 7 over 19. And 8 sevens are 56 over 380. Rightio. So that's it. That's how to find the odds of two independent events. Independent events means one doesn't rely on the other. So just one more for you, and then, because this is new, so we're going to keep it, and we're going to have 6 red and 4 blue. So red red, blue, blue, red, and blue. Okay, so what have we got? For red, it's 6 out of 10, and then it's 5 out of 9. A blue will be 4 out of 9. Now, blue is 4 out of 10 altogether, and now we've got 3 out of only 9 left in the bag, and the reds, 6 reds out of 9. 6 reds, 4 blues, yeah? Okay, so what are we doing now? So we've got, to find the odds of a red, 6 out of 10 times 5 out of 9. 6 5s are 30 out of 90. This is 6 over 10 times 4 over 9. 4 6 is 24 out of 90. This is going to be the same, isn't it? 4 over 10 times 6 over 9 is equal to 24 over 90. And 4 over 10 times 3 over 9, 4 3s are 12 over 90. There you go. So that is how to do multiple probabilities, 2 events to work out what's going to happen with what, out of a selection of different coloured counters, and by keeping them back once we've picked them out of the bag. And that is the little addition to another lesson on probabilities for functional skills.